welcome everyone. I'll let one more person come on in. Welcome everyone to our talk. I'm Izzy.
I'm Matt.
And we work at Hex. And today we're going to talk about the magic behind magic. And there's an important housekeeping item to get out of the way, which is that you were told this is AI Dashboard Karaoke. And unfortunately, it is actually not AI Dashboard Karaoke. We'd initially planned this as kind of like a fun, goofy game show session making fun of the jankiness of AI code and SQL generation. But then we accidentally went and built something that actually is pretty good at generating AI, SQL, and code. And we were kind of struggling to make fun of it. And so we decided that instead of making fun of it, we would crack the hood open and show you all the magic behind the magic and actually show you all the top secret sauce. But then we were like, oh, we can't give away all of our secret competitive advantage. And so we didn't change the title name so that none of our competitors would come watch us do AI Dashboard Karaoke. But actually, you're all going to get the secret behind-the-scenes look at how Hex does AI code generation. So if you were just here for the karaoke, you can leave. I won't blame you. But I promise that this is going to be a really cool, super technical, in-the-weeds talk, not AI hypey at all. We're going to talk about super cool metadata technical stuff. Sound good? Sweet. OK, so there's this great old quote that you've probably heard a bunch of times by Arthur C. Clarke that any sufficiently advanced technology is indistinguishable from magic. And I think it's just a super fun quote. I think about it a lot in terms of Wi-Fi and cell signals and stuff, but also LLMs and AI. And when Hex was developing our internal AI tools, we thought about this a lot, and we actually wound up calling our internal tools magic. So Hex Magic is now the umbrella for all of our AI-enabled features, including some ones that we released just a couple weeks ago that we're going to talk about later today. And so today, we're going to talk about magic. And we're actually going to do a couple magic tricks for you all. And each one will be kind of increasing complexity and power. But then afterwards, like Penn and Teller, we're going to actually show you how the trick is done and peel back the surface and show you the magic behind the magic. And the goal is that by the end of this, you actually know how it's done, kind of trust it enough to maybe actually use it yourself, and that maybe it's even a little more magical now that you know how much work went into making it seem magical on the surface. Let's get into it.
Cool. So for our first magic trick, we are going to generate a SQL query on top of a CSV. Side note, Hex can do SQL on CSV files, which is pretty cool. But we can see here we have a simple order, and we're going to edit it and ask to get a 3-month rolling average aggregated by order, count, and month. Pretty complex query, but Magic's going to just start crushing this. So it'll start generating word by word the entire query. Then it's going to format the whole query to make it look nice, easy for us to read, create a diff. We can then accept this as the code that we want, run it, and get the exact answer that we were expecting. So this is the magic trick number 1. Thank you, Ariel.
Yeah, it never has been working after this. Hang on. OK.
So how is this done? With a little bit of magic. A little more seriously, this is maybe unsurprisingly built on top of GPT-4, which is from OpenAI. And as you probably know, GPT-4 was trained on a whole bunch of data across the whole internet, including Snowflake's documentation, Stack Overflow, and much more. And it's able to generate pretty syntactically correct SQL. Now, the way these things work is that they take in a set of tokens, that initial kind of natural language prompt, and then based on those tokens, it just predicts what's the next token. And so you could see it generating line by line, word by word, what was coming next. Now, the tricky part about this is if your prompt isn't specific enough, it doesn't actually know what you really want. So if you've ever had the experience of Googling DBT, you may have found something out about dialectic behavioral therapy, which GPT-4 will also do. Now, if you tell it that DBT stands for Data Build Tool, then you actually get an answer about DBT, the reason we're actually all here today, and the tool that we all love to use. Oh, I skipped one. I don't know, it's not showing it, but anyways, so it's really important to have a very specific prompt in order to get the best out of GPT-4. And then there's other things you can do beyond just being specific about your prompt. This is maybe something you've played with when you're working with LLMs, is you kind of tell the LLM who it should be. Like, are you a student? Are you a professor? Or are you a helpful assistant and award-winning data science professor who's highly skilled at writing performance SQL and Python code? You always write perfectly syntactically correct SQL. You prefer CTs to subqueries. And maybe you prefer leading commas to trailing. So the crazy thing is that this actually does impact the accuracy of the SQL it generates. But how do you know what exactly you needed to say? Like, is award-winning better than distinguished? Is professor better than professional? These are hard things to just kind of get right without a lot of experimentation. Another odd thing is that LLMs are not deterministic. So even when you tell it specifically not to do something, so in this instance, we're saying, give us the code, no text before or after. It's still giving us text before and after. It's kind of weird. You could then even say specific phrases that you don't want it to say, and yet it still is doing that to you. But in this example, this person from the internet threatened an innocent person's life. And then Bard did actually obey it. So again, like these are hard to determine things. You do have to, again, like experiment quite a bit in order to figure out what's going to make the LM do what you want. And this is something Hex has invested a ton into. So we have kind of built our own eval test harness that takes hundreds of prompts, runs it against hundreds of different versions of the context we provide. And then we kind of see how does that compare against the code we were expecting and if it was generating the actual correct data. And so here's like a snippet of kind of some of our slightly redacted actual context that we passed to the model. And you can see they're kind of chunked out, so we swap these out with different versions. There's too many of these to count. Changing the order, all these sorts of things matter in order to generate better queries. And then the thing that really kind of brings this experience all together is that this is happening inside of a Hex workspace. So you can see, like, while you're generating whatever code you want, it's going to produce data that then you can visualize, you can edit, and so you can kind of work with the LLM and not just expect it to nail everything. You can kind of take what it gives you and make it yours, make it fit your analysis, and ultimately pull off some magic. So this is trick number 1. Thank you very much.
You all thought that was pretty impressive? That was nothing. That was child's play. Matt's over here writing SQL queries against one CSV file. When's the last time you wrote a SQL query against one file, one table? In the real world, we have databases filled with tables and columns and schemas, hundreds of them, thousands of them. And in order to answer real-world questions, you got to figure out how to join them together. Which ones do you want to use? How do they relate to one another? You can't just query one single CSV file. So let me show you what I mean. So here's another demo, another magic trick, I suppose, that I really hope will load fully. Yes. And we're back in Hex. We're going to do a similar thing, use some magic to generate a query. But this time, we're running against a Snowflake warehouse instead of just a CSV file. And we're going to ask it something a little more complicated. How many customers have canceled orders that contain their favorite item? And just like before, we can see magic is streaming back results here, but it's actually joining multiple tables together, doing something a little bit more complicated. But when we keep and run this, we'll again see that it will return exactly the results that we're looking for. I'm going to try and pause this for a second. There's a few things to call out here that we're going to look at a little bit later that are actually really interesting. One, it got the tables right. Yay. 2, it was able to join them together using the correct foreign key, customer ID. 3, a little bit more impressive, it knew that favorite menu items and order menu items were arrays that would need to be flattened and unnested and couldn't just be referenced directly. And 4, and this is actually the most impressive one if you know how this stuff works, is that it was able to do this exact string match filter on order status. and it knew that order status was a completely lowercase word, canceled, not a Boolean, not cancel, not capital C canceled, not all uppercase canceled. And this is actually a really, really difficult thing to get right. And if you were to get it wrong, the entire query would fail because it's an exact string match. So it's pretty impressive. I hear you wondering, I hear you muttering, how did he possibly do that? Can this power be learned? Not from a Jedi. Luckily, all the Jedi are dead. Let's talk about it. This trick isn't actually real magic, dark or otherwise. It just builds on all the things that Matt talked about, a good prompt, an advanced AI, a sweet data workspace, but it adds one crucial thing, which is metadata. And metadata happens to return some of the most boring images on Google image search that I've literally ever seen in my entire life. But I promise you that it's magical and exciting, and I'm going to show you why. It's all about context. So this is our question, our prompt. How many customers have canceled orders containing their favorite item? That's the question you might ask. When you start thinking about what you might need to know to answer that question, even for a simple question like that, you start coming up with a ton of stuff. What's a customer? Are favorite items a profile setting? Are they calculated? What tables even exist in the warehouse? Is there other background info that I need? What tables are most relevant here? Is the dim fact table the one I should query? Should I query a raw table? Are customers going to have more than one favorite item? And wait, how are these even stored? Even for a simple question like this, you wind up with a ton of background information that might be relevant. And the challenge becomes figuring out what information is relevant and what information we can get access to in a structured, consistent manner. And this is incredibly important for dealing with LLMs because they like to do something that we call hallucinate. This is basically when they try to be helpful and they look helpful, but they're just making shit up. And like, if you asked an LLM, hey, generate me a SQL query that joins my customer and subscription tables together, and that's all you give it, it'll do it. It'll just join some random customer table, some random subscription table together based on the statistical likelihood of token probabilities in its training data, but there's no chance that the tables it's been trained on are the exact tables that you have in your data warehouse. It will have just made something up, and it wouldn't have made any sense. And so the way that we game this system and make it work for us is to figure out what information is most relevant and include all of that in the prompt as context so those statistics start working in your favor. When it looks at all of the tokens that it needs to use to predict the next token, it has some actually helpful tokens there. So, time for some audience participation, like any good magic show. Need somebody small, not afraid of tight spaces. We're going to slice you in half. No. Just shout out some things that you might want as context if you were going to answer this question as an analyst. Like, what are the things that you might want to know? Broad strokes, super specific, holler them out. Don't be shy.
Define favorite item.
Yeah, exactly. How do you define favorite item?
How do you find a customer?
How do you find a customer? What is a customer? Exactly. Like, I promise if I really pushed, you would come up with more. There's a bunch of things here. The challenge becomes, which can we get structured, consistent access to, and then which ones do we absolutely need to include, or which ones are maybe irrelevant information. Side note, this is how they do that trick. I know we said we would show you how the magic's actually done. So that's how they do the saw in half. So this is a super simple marketified version of the metadata architecture that powers Hex's context engine for the AI. There's 4 main sources of metadata. One is the actual data warehouse, like Snowflake, BigQuery, Redshift, et cetera. dbt, the actual project context from your Hex notebook, so any data frames and queries you might have there, and then a 4th thing that we'll talk about in a bit, which is the Hex data manager. So let's go through these one by one. First is warehouse data, and we'll keep like a running sort of script of the context that we might include in our query on the right so we can see how this comes together. Warehouse data is like, what tables, what schemas do I have? We have a couple here. We're like everyone else. Our schemas are a total mess. So we have a gazillion dev and prod and staging schemas also. So there's way more tables than are listed here, and we'll just add a ... to show that. We also get column level information, like order ID, ordered at, and what type each of these columns are. This is how we were able to do that lateral flatten. We knew that order items and favorite items were arrays. We passed that information to the LLM, and when it saw that, it was like, oh, this is an array. I need to flatten it. dbt is probably the most important source of metadata for this context architecture. We get information on test status, run history, and most importantly, docs. So if you've written dbt docs, we pull in all of that information automatically from dbt cloud. And when we include a column or a table or a schema in a query's context, we also pass all of that information, originally intended for humans, to the AI so that it has real, grounded, like semantically meaningful context to generate with, or to choose which table it wants to pick. This is starting to be a lot of information, but we are not even close to done yet. You can run these magic generations within the middle of a hex project where you're also doing a bunch of other querying, doing things in Python. So we have things like data frames, other SQL queries you've written, what Python packages you have available. We take all of that, include that in our potential context as well. We also have built something, the Hex Data Manager, which lets you provide custom guidance on top of all of this automatically synced guidance. And I can't seem to make this full screen. But if you really squint, we have this sort of interface on top of all of the automatically synced information from your warehouse and DBT that lets you provide custom guidance specifically for the LLM to guide it exactly how your organization needs it to be used. And you can include, exclude, or prioritize specific tables, columns, schemas, even entire databases to be ranked in the magic generation. So there's a ton of information. In fact, it is way too much information. And it's way too much information for a couple of reasons. Actually, literally just like this demo data set, this demo question on our demo data generated 39,000 tokens of potential context. And tokens are just like the AI's representation of words or SQL clauses or bits of words. And the first big problem here is that OpenAI charges us based on tokens. And if we were to submit 40,000 tokens to OpenAI every single time somebody tried to generate a query, we'd be burning over $1 per query, which is a lot of money. So we need to figure out a way to get this price down and reduce the number of tokens. Second is that these models just have a limit on the context window of information that they can pay attention to. So most of them actually cannot support that many tokens. The most powerful model from OpenAI supports 32,000 tokens. So our 39,000 wouldn't even fit into that ultra max context window, and that model costs double, so it'd actually be $2 each. The third reason is that even if tokens were free and context windows were infinite, we've actually found in our testing, and this is like a crazy, terrible diagram, I'm sorry, that if you provide extra tables on top of the exact tables required to answer a query, the success rate of our generation drops dramatically. You can see this sort of top stream is much, much larger than the failure stream from the exact bucket. We call these distractors. So if you provide something that seems important but isn't actually crucial for the generation, your likelihood of getting a successful SQL query generated goes way down. So we need to figure out how we can be precise and relevant with the tables and context that we include. And there's three big elements to this algorithm, which we call table retrieval altogether. The first part is semi-redacted, something secret we can't talk about, and storage, retrieval and ranking of that information, and then the actual prompt generation. So this is the redacted part. This whole talk is like declassified, but redacted. Maybe someday we'll be able to talk about this, but we'll leave it at that we do something before we store all of this metadata. When we store this data in a vector database as embeddings. So we take all of this information about what columns you have. Really, it would include like all of that extra context from the data manager, from your DBT docs, et cetera. We generate what's called embeddings for it. And if you're not familiar with embeddings, here's what will probably be the worst crash course of all time, so I'm sorry. Embeddings are basically like XY coordinates, like lat longs or Cartesian coordinates, but for some arbitrarily high-dimensional space that the AI model has imagined. And so we generate it by taking that information, say a column name, dim orders, we pass it off to an AI model. That AI model places it, or embeds it, into this strange high-dimensional machine space where it is near things that the model thinks it is similar to. And the really neat thing about this is that it means that similar things wind up being very near one another in this strange space without us having had to specify what similar means or restrict similarity to just one dimension, like title or category. It's sort of this more abstract concept of similarity. And we store these embeddings in a vector database that runs inside of all of our secure architecture right next to the Hex servers. Vector databases are just databases for embeddings. They make it really easy to store and query these sort of strange coordinate embedding vectors. And so when we actually do that querying, when we retrieve information from the vector database, It's a pretty simple architecture. I know this is like a pentagon-style diagram. I wanted to make sure you knew you weren't getting the marketing fluffed-up version straight from the PRD, slightly redacted. But so all these vectors are hanging out in the vector database in little clusters of similarity, things that are like each other, are near one another. And when we get a user query, we pass that to the LLM, and we generate an embedding for the query. And this tells us what this query is similar to. So we embed the query into the same space that we've embedded all of the metadata, and then vector databases let you do distance similarity calculations. And we can basically say, hey, OK, what kinds of things are similar to this question? And this little circle of similarity gives us likely candidates for metadata that is semantically meaningful to the user's query. Although, this gives us a ton of results. And so there's a problem that arises, which is, how do you know if we're returning the optimal amount of tables? Like I said, if you return too many tables, the LLM gets distracted and confused. If you return not enough tables, then that's an automatic failure. And so the question becomes this complicated math formula that we're actually still working on solving that basically tries to find the balance, or tries to find the minimum number n, where the probability of the AI model getting confused with n results provided to it, and the probability of us actually providing all of the necessary tables in n results align beautifully. And we have solved, or not solved, but we can accurately predict and estimate this probability of like how likely are we to provide all relevant tables to the AI in n results. And we do this using that test harness that Matt was talking about. We're still working on solving the confusion part. It's a little bit harder to pin down. But once we've solved this part of the formula and can actually accurately say, OK, with n options for our metadata context, this is how confused or not confused the AI likely will be, then we'll be able to actually like accurately model out the scenarios for how accurate our SQL gen will be at n elements of context. So we're still working on that part. And then once we've done all that work, the actual prompt generation is actually really easy. We just take a prompt template, which was like that thing Matt showed you earlier, and we use it to combine the user's question with all of that metadata, with some other secret stuff, and we put that into the template, pass it off to the LLM, and it gives us that beautiful SQL like we showed you. Just like that. So to like TLDR, the trick, we've basically developed these systems that let us narrow the scope of context in like really clever, really deterministic, controlled ways before we pass that information off to the like non-deterministic Wild West sort of out of control AI model. And this lets us strike a pretty like healthy balance of control versus like AI difficult to control power. So that like regardless of the complexity of your data setup, or if you have 10 trillion tables in your data warehouse, you can actually use Hex to ask questions of your data with AI and get answers that are helpful and tailor-made to your data warehouse. OK, that's the end. I hope you enjoyed our little magic show, that you were equally
You foolish
impressed.
humans. You think this is my full potential?
What?
You write one SQL query and think that you are done with an entire analysis?
Fair.
When is the last time you finished your entire analysis after writing one puny little SQL query?
That's a good point.
Be quiet and let me show you something actually impressive.
OK. Let's see. I'm not going to keep doing the robot voice. For the final trick, we'll bring all the things together that we talked about and add a little more secret sauce to pull off one final trick. So this is what we call magic analysis, where instead of operating at the cell level within Hex, you ask a question at the project level, and it generates a plan for a complete analysis, tells you exactly what it's going to do, which cells it thinks it's going to need to create, which tables it thinks it's going to need, and then it does it. And it writes multiple SQL queries. Here it's actually writing a query against Snowflake, and then it's going to write another SQL query against the results of that previous query, building a sort of CTE-style chained SQL query here. And then it can build charts for you in this Hex workspace and basically kickstart an entire analytical project for you. And the goal is not like full human replacement. Like Matt said, the kind of magic of this is that it's happening in a workspace that we've spent years designing for humans to use to do data analysis, but you're not having to tab back and forth from some other LLM tool. You're able to like access the full power of it, honed onto your specific data stack right where you already do your data work. How do we do it? Magic. And I know this is the part where I tell you how the trick is done, but this one actually is going to stay magic for now. We're, in addition to just running out of time, we just shipped this stuff to private beta like 2 weeks ago, and it's not necessarily like ultra top secret, but we're still experimenting and iterating, and I don't want to stand up here and proudly proclaim to you how exactly it's done before we're 100% certain ourselves. But you're welcome to come up to us afterwards and ask us questions, and we'll happily, without the cameras, tell you how we're doing this and what we're working on to make it even better. And that is actually the end. And we have plenty of time for questions, because I figured there probably are some. So fire away.
So are you guys going to get into metadata as well, like collect the metadata and answer the questions?
Like as part of our product offering?
Yeah.
No, I don't think so. I think that like the data catalog space, it's not like where we integrate all of the metadata from other systems. And then I think there's this interesting addition where like the data manager lets you provide specific guidance for the AI model. And it's actually kind of neat that you have a place where you can provide AI-specific guidance that maybe you actually don't want to surface to humans as part of your like traditional data catalog. So yeah, keeping those separate for now.
Yeah.
Did those demo questions, are they deterministic? Is it going to offer the same sequel the second time around?
That's a good question. Matt, do you know?
We change, like, again, how we are building our prompts pretty often. So as we improve that, it's not necessarily going to stay the same over time. But we would think for a simple, straightforward question, it would arrive at the same thing.
We have a cache, so I don't know exactly what the time to live on our cache is, but if you run the same query or the same question multiple times within some time span, you will get exactly the same result. But outside of that, you might actually get varied results. And that's part of our evaluation and testing framework is like, how can we build prompts and provide context, or how can we get our table retrieval system to be as deterministic as possible, so that, like I said, like the more difficult to control aspects of the pipeline have like less room for error. Does that make sense?
But even if you change for the better, right? It's not going to get worse.
Yeah, hopefully.
Yeah, hopefully.
We're trying.
Yeah.
There's one more question, right? So since you're already working with a SQL, are you planning to do a SQL optimization recommendation? Like you have a huge SQL running on the SQL.
Interesting.
Right?
Yeah.
Query log access, and you can just say, damn, very worst performing query, then I can do like
Yeah. I think that,
tons of money there.
yeah, maybe Matt has more ideas there. I think that we're like, and maybe this probably was not what you're suggesting. I think we're a little uncomfortable with like the secret behind the scenes optimizations, but I could see a world where like we could suggest to you, hey, like this join looks unperformant, like you should do it this way instead.
Yeah,
That would be
you can
cool.
offer another window like this, right? Like the
Yeah.
one that came at the project level, maybe optimization.
We
Just go and look at all the logs, the query logs, and then just recommend.
Great idea.
we actually have like several magical capabilities in the tool. So we were showing off generate and edit, but we have a fixed one. So if there's like a bug, we do kind of different things for that.
Okay.
We allow you to explode CTEs. So I imagine we could add a trick at some point that allows you to optimize a query. It's definitely within the possibilities.
You just purchase 50 user license, and if you guys come with more tricks,
All right, sounds good.
Go for it.
Does the integration of the DBT docs work without DBT Cloud?
This is a question that I never seem to know the right answer to. It definitely, this could be wrong. This could be false information. It definitely automatically syncs if you have DBT Cloud, and it's sort of, you make a pull request to DBT, it automatically shows up in Hex. I think there might be a way for you to upload manually, but obviously you would need to do that every single time you update your DBT docs, and that might not even be true.
I don't think we update them that often.
Well, I can figure it out for you later.
I actually have the same question.
Okay, all right. Yeah.
How can I get started with Hex?
Very,
Go for it.
very easily. Go to hex.tech and sign up. We have a community free tier as well as multiple paid tiers for per seat per month. Yeah, and you get a free trial, and you get to talk with us about it, and
Yeah.
happy to help you.
And all these features are available on our free plans as well. You have like a limit to the number of questions you can ask because, like I said, like they do literally cost money every time, although they don't cost $1, thank God. but I think it's a pretty generous limit for the free tier. So you can experiment with all this stuff for free. Yeah.
Is it SQL only or Python as well?
It generates Python as well. That's a much easier problem to solve because you don't have to deal with all of that, like all this metadata retrieval stuff. There's still some elements of it that are important, like I showed you the project context. So if you're writing Python, it needs to know what packages have already been imported, what data frames it has, et cetera, but it's not as complex as the SQL generation, like table retrieval architecture.
In your testing, do you find that true?
Massively so, yeah. We've spent a ton of time tuning our SQL generation, and from the moment we began doing this, our Python generation, and just like the acceptance rates, because we can see, I don't know if you saw, but there's like a keep or reject option, and our acceptance rates for Python from the very beginning have been like really, really, really high.
So I can see this being really valuable for like us in the room, like the data nerds working on it. I can see my stakeholders wanting a magic box where they can type in the questions. I'm curious, the thinking, like, so I can see like creating a curated area where we spent all this time building up the docs and the key tables for some stakeholders around our bookings or our opportunities. And I can see like the VP of CS wanting to ask a question around how are my losses looking this month? Is that something that I could have a box type into at some point? Because for now it's kind of locked in the app there, but I'm curious if that's something we can get to stakeholders.
Well, I mean, our head of sales uses this now. So, I mean, it does still generate SQL code or Python code. And you have to run that because we still feel like you need to be able to evaluate what it's saying there and not just fully black box it. But yeah, I mean, we have people internal at Hex who do it today.
I think I'm not in charge of the Hex product, but I think that part of the joy and like magic of this is that it does really tell you what it's doing in like pretty detailed technical level, both like with the plan that it generates, tells you what tables it's going to use. You can see the SQL, you can tweak it, rerun it, and I think that at least for the technical audience, is like it's almost like a totally different product you can imagine to like a magical Oracle black box that you ask the question to, but probably someday.
Yeah, I want to figure that out. Anyway, okay, thanks.
As long as you write your field names using like relatively intuitive naming conventions, does it actually? Do you have to give it field names, or can it kind of parse the field names and figure out what they mean?
Oh yeah, it parses them. Here, like let's go back and look at something. Here, it's like pull monthly revenue and cost information broken out by category, and I misspelled spiciness there actually. And we'll see once this actually starts generating, it's like, yeah, it's grabbing category, which I did mention, but it found is spicy, which is not exactly the same as like spiciness. And I think it'll grab things for revenue and cost, like it's gonna do a sum of sales for daily revenue, a sum of price as daily cost. So it's able, that's like the magic behind the semantic search mapping. It's able to say, okay, here's a query or a question that includes revenue and cost information. Like what things that I know about are kind of similar to the word revenue, and it's able to be like, oh, okay, like sales is probably relevant to that. And so it is able to do that kind of like fuzzy mapping, yeah. Yeah, well, and that is part of the like custom guidance that you can provide as part of Data Manager. Like, where did I talk about it? The reason that it was able to get this canceled is because in the Data Manager we told it, like, hey, here's the options that are available for order status. They're lowercase words, canceled, complete, pending, et cetera. So you might want to add in your custom guidance, like everything is snail case or something like that.
That being said, making it a more intuitive name is going to make that fuzzy searching easier. If it's too cryptic and you don't have any documentation supporting it as well, that's going to be much more challenging.
So, sort of on the topic of parsing some of the metadata from the DBT project to get an understanding of how these different components of the data model fit together, have you, I don't know, sort of looked into the DBT semantic layers and other sorts of metadata for maybe you're talking about a hospital and you want it to be able to tell that there are many different maybe aliases of primary keys that could be associated with that single entity.
Yeah, I think we don't have that as part of the metadata system today, but it's going to be really powerful once that is added. I think that I'm spacing the name of the person who wrote this blog, but there's a cool blog post somewhere out there of somebody arguing in favor of like not using AIs to generate SQL, but of using AIs to generate like instructions for semantic layer, like modeling type tools or like ORMs. Oh yeah, it was an engineering post about like why you should use AI to generate like ORM queries instead of SQL queries, because then you can use that intermediate layer. I think it's pretty cool. Anything else? Thank you. Sorry it wasn't karaoke.